Okay, stop scrolling for a second. I need you to listen to this because, frankly, it's not making the headlines it should be. We all remember 2020. We remember the masks, the lockdowns, the sheer confusion of it all. But while the world has been busy trying to get back to normal, something else has been brewing in the background. Something quieter. Something smarter. It is January 2026. The World Health Organization has just issued a series of technical briefings that, if you're not a virologist or an epidemiologist, probably look like boring paperwork to you. But if you read between the lines, which is exactly what we've done for this video, it paints a picture that is, to put it mildly, terrifying. They aren't calling it a pandemic just yet. They're calling it a convergence event. We are talking about biological threats that don't just make you sick. They change the fundamental rules of medicine. We're talking about organisms that eat the very drugs designed to kill them. We're talking about threats jumping from animals to humans in ways we didn't think were possible this quickly. Today, on Top Tier Facts, we are breaking down the 5 silent threats that the WHO is warning us about for 2026. These aren't sci-fi. These are already here, knocking on the door. And trust me, number 1 is going to make you look at your own medicine cabinet very differently. Let's dive in. Item 5, the post-antibiotic era. Coming in at number 5, we have the slow-motion train wreck that scientists have been screaming about for decades, antimicrobial resistance, or AMR. Now, I know, resistance sounds boring. It sounds like something that happens in a petri dish, not in your real life. But in 2026, the data is showing a shift that is honestly hard to process. For the last 80 years since the discovery of penicillin, we've lived in a medical golden age. You get an infection, you take a pill, you get better. It's magic, but that magic is running out. The WHO's 2026 report highlights a surge in what they call pan-resistant bacteria. Pan means everything. These are superbugs that are immune to every single antibiotic we have on the shelf, including colistin, which is basically the nuclear option, the drug we only use when nothing else works because it's so toxic to the human body. Imagine cutting your finger while chopping vegetables. A simple slip. In 2015, you put a Band-Aid on it. In 2026, if that cut gets infected with a pan-resistant strain of Klebsiella or MRSA, there is physically nothing a doctor can do for you. It's like returning to the year 1900. Routine surgeries like C-sections, hip replacements, or even chemotherapy become a game of Russian roulette. Without antibiotics to protect the patient, the risk of infection becomes too high to justify the procedure. The report specifically mentions gram-negative bacteria. These guys have a double layer of armor around their cells. Our drugs literally bounce off them. And the scariest part? They are sharing their armor. Bacteria can swap DNA like trading cards. So if one bug learns how to beat our drugs, it can teach the bug next to it. We aren't just fighting a disease, we are fighting a networked intelligence. But bacteria are old news, right? We've been fighting them since the dawn of time. What happens when nature decides to upgrade a different kind of organism? Something that usually minds its own business, but has recently decided that the human body looks like a pretty nice place to live. If you watch The Last of Us, you might want to sit down for number 4, ITM4, the thermal adaptation of fungi. At number 4, we have the kingdom fungi, specifically the rise of Candida auris and other thermally adapted fungal pathogens. Here is the biological reality. Humans are hot. Our body temperature rests at about 98.6 degrees Fahrenheit, 37 Celsius. This is too hot for most fungi to survive. It's our thermal shield. It's why you get athlete's foot on your skin, but you don't get mushrooms growing in your lungs. Usually. But the world is getting hotter. And because the environment is getting hotter, fungi are evolving to survive in higher temperatures. They are training. They are adapting to the heat. And now, the gap between the outside temperature and the human body temperature is closing. Candida auris was first identified in 2009. Back then, it was a mystery. Today, in 2006, it is a global health threat level red. This fungus is practically indestructible on surfaces. If a hospital room gets infected with Candida auris, they sometimes have to rip out the floorboards and ceiling tiles to get rid of it. It creates a biofilm, a slime that protects it from bleach and other cleaners. But the horror story isn't about cleaning products. It's about what happens when it gets into your blood. Unlike bacteria, fungi are eukaryotes. Their cells are very similar to human cells. This makes killing them extremely difficult because any poison that kills the fungus is likely to kill the human host too. We have very few antifungal drugs, and C. auris is laughing at them. The mortality rate for an invasive infection? It can be upwards of 60%. The WHO 2026 alert points out that we are seeing spillover events where fungi that used to live exclusively on plants are now showing up in human spinal fluid. The thermal shield is failing. We are losing our natural immunity simply because the planet is warming up, so we have superbacteria and heat-resistant fungi. That's bad, but surely we can just avoid them, right? Stay clean, wash your hands. Well, that works. Until the vehicle delivering the disease is something you cannot see, taste, or avoid because it's in the water you drink and the air you breathe. Number 3 is small, synthetic, and it's everywhere. ITM3, the microplastic vector. Number 3 is a curveball. You've heard about microplastics. You know they are in the ocean, in the fish, and probably in your bloodstream right now. Recent studies estimate we eat about a credit card's worth of plastic every week. Delicious, right? But for a long time we thought this was just a pollution problem, a mechanical issue. The 22,000 HWH briefing changes that categorization. They are now classifying microplastics as pathogen vectors. Here is the science. In the ocean, or in wastewater, plastic particles don't stay clean. They get covered in a layer of slime called the plastosphere. This is a mini ecosystem that attracts bacteria, viruses, and toxic algae. The problem is that these plastic rafts travel much further than the bacteria could on their own. They are like cruise ships for diseases. But it gets worse. Research has shown that bacteria on these microplastics are actually more aggressive. The close quarters on the plastic surface encourage them to swap genes faster. Remember that DNA trading card game we talked about? It happens on steroids inside the plastosphere. The WHO is warning that we are seeing untraceable outbreaks, people getting sick with cholera or rare gastrointestinal viruses in areas where those diseases shouldn't exist. How did they get there? They floated in on microscopic pieces of polyester from our clothes, or tire dust from the roads. The wind blows, the dust settles on your crops, you eat the salad, and suddenly you have a pathogen that hitched a ride from 3,000 miles away. It turns the entire model of quarantine upside down. You can stop a person at the border, but you can't stop the dust. Okay, plastics are carrying diseases. That's gross. But at least those diseases are still somewhat human, right? They are things we recognize. What keeps epidemiologists awake at night, the stuff that makes them drink, is the idea of a disease crossing the species barrier from an animal that acts wrong. A disease that turns the host into something else. Number 2 is straight out of a horror movie. ITM2, chronic wasting disease, the prion threat. Number 2. We need to talk about prions. If you don't know what a prion is, it's not a virus, it's not a bacteria. It's not even alive. It is a protein, a misfolded protein. Imagine a zipper on your jacket that gets stuck. But because it's stuck, it forces every other zipper it touches to get stuck too. Currently, North America and parts of Europe and Asia are dealing with an epidemic in deer, elk, and moose called chronic wasting disease, CWD. The colloquial name is zombie deer disease. And for once, the media isn't exaggerating. Infected animals lose their fear of humans. They drool excessively, they stumble. Their brains slowly turn into Swiss cheese. They literally waste away until they die. It is 100% fatal. There is no cure. For years, the species barrier protected us. We thought CWD couldn't jump to humans. But the 2026 alerts are flagging ambiguous neurological clusters. This means they are finding groups of people with rapid onset dementia or Creutzfeldt-Jakob disease symptoms in areas with high CWD rates. Prions are terrifying because you cannot kill them. You can boil them, radiate them, dip them in acid. They stay infectious. If a deer dies in the woods, the prions seep into the soil. Plants grow from that soil. The prions go into the plants. Another animal eats the plant, it gets infected. The WHO is worried about the silent incubation. Prion diseases can hide in the body for 10, 20, sometimes 30 years before symptoms show up. By the time you realize you're sick, it's already too late, and you might have exposed others through blood donations or surgical instruments. Because remember, normal sterilization doesn't destroy prions. The fear for 2026 isn't a World War Z outbreak where everyone turns in seconds. It's the fear that the jump has already happened, and we are just now starting to see the first cases emerge. Prions are nature's glitch. They are scary because they are inevitable. But the number one threat on this list isn't an accident of nature. It isn't a glitch. It might be something far more intelligent, or rather, something created by intelligence. The final alert for 2026 concerns the one thing we can't predict: the unknown. And here we are at number 1, the concept of disease X. For years, the WHO used disease X as a placeholder, a variable in an equation for a hypothetical virus that we haven't discovered yet. But in 2026, the definition of disease X has shifted towards something specific: synthetic biology and dual-use research. Technology has democratized creation. In 2010, sequencing a genome cost thousands of dollars and required a massive lab. Today, you can order DNA sequences online. You can buy a CRISPR kit for your garage. The barrier to entry for manipulating life has collapsed. The WHO alert warns about the accidental leak or the engineered event. We aren't just worried about a bat biting a pangolin anymore. We are worried about a lab researcher trying to make a virus more studyable and accidentally making it more transmissible. Or a bad actor realizing that biology is the poor man's nuke. But it's not just malice, it's complexity. We are mixing genetics from different species to create new medicines, new crops, new materials. We are creating organisms that have never existed in the 4 billion years of Earth's history. If one of these synthetic organisms escapes containment, it enters an ecosystem that has no defense against it. It's an invasive species on a molecular level. The 2026 alert focuses on respiratory transmissibility with long incubation. That is the nightmare scenario. A virus engineered, accidentally or on purpose, that spreads like the flu but has the mortality rate of MERS or Ebola. The systems we have built, the surveillance, the vaccines, they are all designed for natural threats. We are not fully prepared for artificial ones. The silent preparation, I know, that was heavy. It's a lot of doom and gloom. But here is the flip side, and the reason why the WHO releases these alerts in the first place. Knowledge is the only shield we have. The fact that we are identifying these threats, tracing the microplastics, tracking the prions, monitoring the superbugs, means we aren't flying blind. The silent pandemic stays silent only if we ignore it. In 2026, the biggest act of rebellion is staying informed and staying healthy. Support science, demand better regulations on antibiotics and plastics, and keep your eyes open if you want to dive deeper into the rabbit hole of biological mysteries, or if you just want to know how to prep without looking like a crazy person. Make sure you hit that subscribe button and ring the bell. We dig through the documents so you don't have to. Stay curious, stay safe, and I'll see you in the next one.